Hello guys, in this video tutorial we are going to discuss AMF Selection Logic. Okay, so we know in legacy 4G networks the node be usually like just doing a round robin traffic selection to a pool of MMEs. In 5G, because of network slicing, routing is no longer just about load balancing, it is about finding the specific core nodes that is physically and logically equipped to handle that specific enterprise or consumer slice. In phase 1, we are going to discuss like how RAN level selection of AMF can be handled. Okay, suppose like UE wakes up, okay, and send kind of RRC setup complete messages, and it contains NAS registration request. Okay, that also includes requested slice. You can say requested NSSAI and its temporary identity, and that is 5G STMC. Okay, now the GNode B has a strict kind of three-step decision tree. Like it need to figure out like where to send that particular traffic. In case of valid GUAMI, like if UE provides a global unique AMF ID, like it is recently attached to a specific AMF kind of, then GNode B is going to try to route it right back there. Okay, if there is requested NSSI, okay, it is used like when there is no valid GUAMI present, GNode B looks at the requested slices, and if the GNode B local routing table knows like which AMF will handle those particular slices, it routes the traffic there. Okay, then the another option is the default route. If GNode B is blind, okay, maybe the UE is asking for a highly specific enterprise slice the GNode B doesn't recognize, then it is going to fall back to the default, or you can say initial AMF. Okay, now in phase 2 we have the core level of AMF reallocation, or kind of, and it is done via NRF. So now the default AMF has the packets. Okay, it evaluates the request and realizes, okay, I'm not authorized to or equipped to serve that particular requested NSSI in this kind of tracking area. So instead of rejecting the UE, the 5G code uses its service-based architecture to find the right nodes. Okay, the initial AMF queries the directories, the NRF. Okay, it sends an NRF NF discovery request, like asking give me list of AMF in this PLMN that support this particular requested NSSA, and in this particular TI, you can say tracking area identity. In that case, another NRF kind of replies with a list of capable target AMF profiles, including their IP addresses, their current load capacity, and then here like the initial AMF like selects the target AMF from the list, okay, based on the load balancing and kind of the priority configuration. Now in phase 3 we have NAS message rerouting. Okay, so this rerouting, or you can say handoff. Okay, now instead of forcing the UE to restart the entire radio connection, the core handles this reroute internally. This AMF, or you can say initial AMF, takes UE's original NAS message or NAS registration request and forwards it directly across the core network to the target AMF. So it uses the AMF communication, and AMF communication is a station status update service API. Now the target AMF acknowledges that and then take the ownership of that particular signaling session. And now in the stage 4 we have the registration continuation. Okay, so here like it now AMF is going to reach the UDIM and AUSF. Okay, so it reaches out to AUSF and UDIM to fetch the authentication vectors and validate the subscriber profile. Once authenticated, the target AMF builds NAS issues and accept message. It includes allowed NSSAI and a new 5G GUT to this new target AMF. It sends this back down through the G node B to the UE. Okay, now from this point forward, the default the UE will bypass the default AMF and will be talking directly to the target AMF. So this is that's all from this particular video lecture. I will see you in next slide.